You have seen now all that you need to know in order to write actors and have them interact with each other, but one thing is missing. Testing actors is integral to developing them, as we will see. You will notice when testing them, when you have, for example, chosen a messaging pattern which does not lend itself well to testing, and that might be a hint that the design is also not so well suited for production. For example, if you couple components too tightly, you will notice during testing. Therefore, we will look now at the tools available in the Akka tool belt for this purpose. The first thing to note about actors, remember, is that they only interact using message passing. There is no way to reach into them and to check their current behavior without sending a message. And all you can ever get is a message back. This is what I mean when I say that tests can only verify externally observable effects. An example. This actor called toggle has two states, happy and sad. You can ask this actor how it feels right now, and it will reply with either happy or sad, and on each reply it will switch its behavior. How do you test this actor? Well, there is only one way to do it. We must send it "How are you?" messages, and then we must observe which replies we get back, and they should alternate between happy and sad. Akka comes with a test kit, which makes this task quite easy. The central piece in it is called test probe. A test probe is like a little remote-controlled actor. Its only purpose is to buffer incoming messages in an internal queue so that they can be inspected from the test procedure. When we write a test, we need to start the whole system, and we cannot use the akka.main class for this purpose, which we have used so far. Here you can see how to explicitly create an actor system. Like actors, actor systems also have names. We call this testsys. Then we make this system implicitly available. The second step is to create our actor under test. We create a toggle, and then we create a test probe. Creating a test probe also creates this little actor inside, for which it needs the system, and the system is picked up implicitly in this case. Now we have two actors, the actor under test and the probe, and they can have a little chat. The probe sends to the toggle, "How are you?" And then the probe expects the reply back, "Happy." When we do the same thing again, the expected reply will be sad. When we try to send something which the actor does not handle, we did not foresee a case for that, so the actor will not react to this. So we do not expect a message, and we wait for 1 second. That should be enough to verify that no response is received. Since we created the actor system in this test, we also need to make sure to properly shut it down, because otherwise the threads which it creates will keep running. You might have wondered about system.actoroff, because so far we have only seen context.actoroff, and the context was that one of an actor, meaning that only an actor can create another actor. System.actoroff does the same thing behind the scenes. The actor system comes with a so-called guardian actor, and system.actoroff sends a request to that guardian actor to create this actor for us. The test probe is a little actor which is driven from the outside, but we can also use the test probe from the inside. We can run a test in the context of a probe. This is done by using the testkit class, which is initialized with an actor system. Inside this class, the system is available with the name system. The trait with implicit sender makes the internal small actor available implicitly so that it will be picked up here when we send messages. The sender, which is picked up automatically here, is named test actor. and is an actor ref which you can also use in this test if you need to send it explicitly. The second thing to notice is that we use expect message without a leading probe dot. This is because expect message is a method on testkit, so it is directly available here. But then the test runs in exactly the same fashion, and at the end we still need to shut down the system. Some of the actors which you want to test will have external dependencies. For example, they need to talk to a database or a web service of some sort, and you do not want to use those, the real ones, for testing. The traditional solution to this problem is to use dependency injection, to use different, for example, database handles during tests, during staging, and then in production. You can use the same approach with actors. You could use, for example, Akka together with Spring. If you Google it, you will find how to do that. We will look at a very simple solution here, which is to simply add overridable factory methods. For example, let's look at the receptionist. The receptionist needs to create a controller under certain circumstances, and if we hardwire the props controller in the actor of call, we cannot stub it out in a test. What we can simply do is to add a method controller props, which gives these props with the known behavior, and this allows us to override this method in a test to create a different actor which, for example, does not really go to the web to retrieve the links. Or talking about that, if we look at the getter used web client get URL. If we want to switch out the web client from the real one, which I've renamed async web client here, to a fake one, we can just insert this method as shown, and then the test can override it. Let us look at this in practice. I have renamed the web client object to async web client and factored out the interface web client here with the get method. Within the getter, this def gives the async web client, which is used here. Next, I have prepared some code to fake a web client. First, we start out at a certain link, and we take the actual HTML document which shall live at this link from this body's map here. And there is a links map, which for this link also has the desired output of the getter, the sequence of links encountered. Then we create a fake web client which implements the web client interface. When we get a URL, we look simply in the body's map, and if there is none, we give a bad status 404, not found. If there is one, we give a successful future with the body. We can inject this into a getter, as shown here in the fake getter method. This returns props describing how to create a getter which uses the fake web client. We say props new getter, and then we override in an anonymous class definition what client means, and we say this shall be the fake web client instead of the real one. Before we can test the getter, we need one more thing. The getter actor sends to its parent, and that is what we want to verify. But the parent is something, if we have the system create a getter for us, then that would be the guardian, and that would not be very useful because we cannot monitor what gets sent to the guardian. Therefore, we need to create a step parent for the getter. The step parent is an actor which takes a description of how to create a child and the probe to which all messages shall be forwarded. It then creates the child, and whenever it receives a message, it sends to the probe with the tell method to send the message and to keep the original sender so that what arrives at the probe seems to come from the original sender. So it will seem to come from the getter in that case. Before using that on the real getter, let me show you a slight variation of this pattern. If we want to inspect all the messages which are exchanged between a child and a parent in both ways, then we could create a foster parent, which mediates between the child and its real parent. The foster parent again gets the description of how to create the child and the probe. Now it needs to remember the child actor ref, because whenever the context.parent sends a message, then in addition to forwarding the message to the probe, we also forward the message to the child. This forward here is the same as shown previously, so it will use tell with the current sender as the sender argument. If we receive a message from another actor, presumably from the child, then we send it to the probe as well, but we forward it also to the parent. This way, this foster parent is nearly completely transparent for all messages sent between parent and child. The only thing which does not quite work is if one of those two would expose the ref of this foster parent to external actors, because for that we do not have the necessary logic to find out where the message should have gone. Now we are ready to write the getter specification. Class getter spec extends testkit with an actor system with an appropriate name, and I am using Scala test with the word spec like. Before and after all is needed so that after the tests have run we can shut down the system. An implicit sender is needed, as you have seen, so that messages sent will have the right sender. Here we have the specification of the getter, and it has two test cases. In the first one, we create a step parent for a fake getter, which starts at the first link of depth 2, and we want to verify that we get the right response. The name we give to this test case main actor is writeBody, so we can see if something goes wrong. We look into the links map, which we have in the test case for the first link, and for all links we expect, we say expect message controller.check link at depth 2. And finally, the getter must terminate the exchange by saying getter.done. In the second test case, we try to retrieve a URL which does not exist, and we only expect getter.done. If you installed the Scala test plugin for the Scala IDE, then with the right click in the context menu under Run As, there is Scala test file, and if you click on it, the test will be run. And we see the bar is green, everything has worked. Another example we can look at is how to test the receptionist in isolation. For that, we need to create a fake controller. The fake controller here will be an actor, which when it receives a check will just sleep for 1 second, simulating that something takes time, and then it will send back the result. But wait a second, did I just say sleep? Actors shall not sleep, so let's fix this. We can replace this by the scheduler. Much better. This is just test code, you might say, but remember, you need to think that actors should never block, and not practicing it anywhere is a good way to achieve that. We wire this fake controller into a fake receptionist, again by saying props new receptionist, and then in an anonymous class we override the controller props to be pointing to this fake controller instead. The receptionist spec works in the same way as the getter spec by using a test kit with an actor system, this time with a different name to make it clear which test is currently running. Word spec like before and after all with the shutdown and the implicit sender. And here we have the test cases. In the first test case, we verify that the result is returned as specified. We create a receptionist using the fake one, and we send it a get for my URL. This is tested completely in isolation. It will not call any getter, so any string will do. We expect back the message that the result for this my URL is exactly the set with just my URL in it. The other thing we are going to test is that the receptionist properly queues and rejects requests as we have designed. So again, we create one with the name reject flood, and we send it 5 requests, each with a different string, so that we can disambiguate them. First, we expect the failed for the last one, where the queue should be full, and then we expect the other ones exactly in the order in which we sent them. Running this test, will take a little longer because we built in the 1 second delay, but the bar is green, everything worked. When testing actor hierarchies, so you have collaborating actors which work together and some are parents of others, you will of course want to test each actor in isolation as much as possible. But what you should also do is to work your way up the hierarchy by starting out from the leaves and then spawning the supervisor, which will create the children actors in the test, testing them all together. This is more integration testing of your actors, and since you go from the leaves outwards, you're adding shells on top of what you currently have. I call this reverse onion testing. It's like not peeling back the onion layers, it's like putting them onto the onion. With the techniques shown in this lecture, you should be all set to begin the exercises and successfully complete them. I wish you the best of luck.